Hey, Matt.
Hey, Mike.
The podcast. What, the podcast? Question mark?
Yes?
Welcome to Hacking the Grepson, where we make references to old Flash animations that were once popular on the internet and are still popular, actually. Strong Bad is still a thing. The brothers, whatever, that make that are still making new episodes of that world. It's crazy on YouTube. Check it out.
Recently, too, I think they had a comeback.
Yeah. Like, it's funny how that, I mean, lots of stuff that was, like cool years ago comes back, culture as a cycle. But I didn't see that one coming back, but I'm happy that it did because it's good, wholesome fun,
Indeed.
So what we're going to talk about today is email. No, what we're going to talk about today is something that email might be used with, and that is an API, which stands for an application programming interface. Now, those three words all mean things in and of themselves, and together they mean other things. And what is an API? What is considered an API? I have some opinions, but I'm not sure I have as many opinions as my podcasting my podcasting mate.
Good eye.
So let's get things started off with, when I say API, what does your mind immediately think I'm talking about?
At its most basic, an API is a way to get information out of a program. Or into, for that matter. It's how you talk to a program.
Right.
Or a piece of code.
I mean, right. At its basic, like if I wanted to get information, if I wanted to get the string hello world out of another program, and that program had a hello world function that printed hello world to the screen, and I called it from my computer or my program, am I using an API?
Maybe.
Okay. But please, what is your experience with, have you ever worked with an API, and what was it, and how did it make you feel, Matt? What was the most recent API you dealt with, and how did you feel about it?
I don't think you can be a software programmer without dealing with an API. At the very least, you're writing your own for yourself, even if you're just like a solo dev. Plug for our previous episode. You still got APIs. The class that you write, the functions that the methods that exist in it, that's an API. It's like, here's the function call, and here's what it's going to return. And it's like this contract that you are not signing, but effectively that you're agreeing to. It's like, I will provide this API, and when you call it with this information, I will do something, right? So an API could be to write hello world on a screen. That's a little weird. Usually you would consider APIs often are about either putting or getting information, right?
Right.
So if you were writing email client, right? There's a server, and there's your client, and your client needs to talk to the server. How does it do it? That's an API, right? It says, hey, give me mail for Matt. And it says, hey, I have 1,000 messages for Matt. And you say, okay, give me 10 of those.
Mm-hmm. Yeah, there might be a function in the API of that mail server that is like get mail and takes an argument of like a username and how many messages to return at a time. And you would call that and it would give that to you. To use a more concrete example of something I've done recently, just to stir the pot, is I was going through a tutorial, and one of the things they wanted you to do was use the Mapbox API in order to get maps to display on a web page. So basically, you would make a call in your code to, Mapbox API get map, and you would give it like latitude and longitude coordinates. And then if that worked, and their server said, okay, here's your stuff. Your program receives an image of a map that is centered on that latitude and longitude, and then you can display that as like an SVG or whatever, or PNG on your computer. So I have successfully accessed an API using the verbs that it wants, which is get map, and the data that it wants, which is latitude and longitude, and returns it.
I think the most recent API I've used, to answer the question you asked me that I totally dodged, is probably GitHub's API. We're doing a transition over to using GitHub, thank goodness, from a different Git server. And I have a service that, among other things, communicates with our Git server and does operations on it. And previously it had to work with Bitbucket, and now it's going to have to work with GitHub. So I had to learn this new API. How do I get a list of commits for this pull request? How do I get a list of pull requests, right? Differs between different things. And I mean, they mostly, because this is and we'll circle back to this word I'm about to use, but they're REST APIs, or RESTful APIs if you really must. REST. They're REST APIs.
Oh, I do must.
I don't must.
I shout.
I run them mostly from the command line while I'm trying to figure it out. Then once I'm like, okay, that's what that looks like, then I pull it into my program. But I've been doing quite a bit of that lately. It's like GitHub APIs and Bitbucket APIs and Slack APIs and all sorts of fun stuff.
I think another one that like I've probably done many times over, like when learning a new like web programming language or something, is making a blog. And a blog definitely has a pretty standard API, meaning that if you want to interact with that blog from a web browser, which is a very popular way to interact with APIs these days, every website you visit essentially has some kind of subset of the REST API, which is like get is a verb, like give me data, like give me a blog post or give me a news article, or post, which is like I'm adding a new blog post to the list of blog posts. Or there's also patch or put, which is often like I'm updating an existing blog post or news article that exists. There's delete because you want to remove it. And all of those verbs are kind of like standardized so that when you're running a website, other programs, like I said, like browsers, or if you have a program that needs to get this information from a site and pull it in to display or use somehow, it's nice to have that standardized set of verbs that you can assume the web server is going to understand and comply with. And that's kind of the interface part of API, which is not web specific. I mean, like that's just programming specific, where you write interfaces in your code saying like, if you're going to use this module or this class, like you said, here are the things that will be provided. Here's the functions. Here's what they take. And if you're going to say use those in your own code, you have to follow that interface when you're programming.
So interestingly, I would not consider things like get and post and put and patch to be APIs. I would consider them, those are specifically like HTTP methods, is how I think about them. But what you do with those, that's the API, right? So typically, and specifically the ones that you talked about, like you would have a CRUD interface is what it's often called. Just create, read, update, and delete. And for that, you would use post or put to create. You'd use put or patch to update. I skipped read, which would be get. And then delete is delete. And that tends to be more how people think about it, I think. And when you're talking about REST APIs specifically, there is that's where you get that the specific things I was talking about, like post, like you were saying, is how you create a new thing. And if you want to distinguish that between post and put, because you can also use put to make a new thing, it's usually, do you know the name of the thing or the ID of the thing? Well, then you use put. If you don't, and you're like, you give it, here's information, you give me back whatever the ID is, great. But if you were like, okay, I'm going to create a user called M. Messerman, you could use put for that generally. But that's all dictated by REST, is using those methods in that way. to give
Thank you for that clarification. Yes,
common,
you're very right.
a common sort of standard approach to accessing data.
And I would say that like even just that is kind of I think that that kind of system really for the web really came around in Web 2.0.
I think so, yeah.
Which was Web 1.0 was people putting up a lot of static sites that didn't talk to each other. And then Web 2.0 was all about talking to each other. So all these web servers or web, like the software or your program that's running on it, has to start providing an API. Like when you think about getting data from, literally any company that has content that you want to get at for whatever reason, they often will provide an API so that programmers can get that information. And you're right. They'll use all those HTTP verbs to say, hey, I want to do this stuff with your data. And then they implement that in the way that makes sense for their site and their content. And I'm trying to think of like, before we had that, like if you wanted to get, like, let's say, mainly because I used to work in the insurance field, not as an insurance salesman, but just as a computer guy in an insurance agency, like let's say you wanted to get a bunch of leads, like a big spreadsheet of leads of people that you want to, unfortunately, probably cold call to see about their insurance needs. If you didn't have this kind of API on the web, you might just have to go to a company and ask for like an export of a spreadsheet or a database.
Yeah, can I have a CSV of that?
Right. Yeah, you had to get a flat file. Everything was like exported to a flat file because there was no way for my computer to easily talk to their computer and get stuff back.
And there certainly wasn't a standard for it.
Standard.
Like I remember I turned some blogging software in the late 90s, early 2000s, I'm not sure which one, into effectively a bug tracking software. It was all written in Perl, and I took this blog software and I ripped it apart and I put it back together. But it had an API in it, which was, it had a client, a front end face, which is the part I didn't want to write. And then it had a back end written in Perl. But it was definitely not using REST. It was like, it had very bespoke types of interfaces. It's like, if you want to create a post, I think you it used a get with a query string, like query parameters to like create the post. It was all done wrong by today's standards. But this was like 1999, 2000. So we didn't know better.
Matt, I mean, have you specifically had to write code that you knew was going to be, like, I guess like a library, that would be used by other people? So you had to really think about how it would be used by anyone as an API?
Oh, many times. Yeah.
Yeah.
That's a fairly common thing that I've had to do throughout my career. As someone who often works on the back end, that's probably why.
Are there any things that commonly come up that are like really important for someone to do when they're writing code that's going to be used like that?
I think probably the most important thing is, so I like to say, my daughter's going to be driving soon, which is terrifying. So when we're driving, I talk to her a lot about how bad other people drive. And I say the most important thing as a driver that you can be is predictable, which I heard from somewhere. So then if you're predictable, other people know how to react to you, right? If everyone's predictable, we're good. And I think for APIs, it's actually also that. It should behave in an obvious manner that you can easily follow. You don't have to think about it. If you're doing something like REST, you follow those methods the way we talked about earlier. You don't use a get to create a new thing. That's wrong. So the more consistent you can be with other APIs out there, and the more you can like, if I use a get call, I expect it not to modify anything, right? That is an expectation that I now have of APIs that 20-something years ago I did not have, because the tool I was using used get to create things. And I still see it every once in a while. So I think there's that. Also with REST, you have things like how you name as you go through the path in a RESTful interface, You were talking about like blogging software, so you might have like posts, and if you do a get at the posts, you know you're going to get a list of the posts, right? Or at least a list of all the identifiers of the posts, and then you can do, get post /1, you're going to get post number 1, right, and so on and so forth. So following that standard is is honestly really critical, I think, to writing a good API, because you don't want to confuse people. Most APIs that I've had to use in my career are awful, and they're really hard to learn. So I really liked when REST became kind of the de facto standard, because once I understood how it worked the same way basically everywhere. I'm like, okay, what is the path to the posts on this one? Okay, they call it posts. This one calls it reports. This one calls it messages, whatever. But it behaves the same way.
Yeah.
And then good documentation. I think it's the other really important part of APIs. Here's the thing. Here's what it does. Here's what how I expect the input to come in. Here's what each of those fields mean. Here's the input you're going to get out. Here's what each of those fields mean. And that is not great in most APIs.
Now, I want to kind of go off on that because is that a tech problem or is that a human problem? Is that people are just chaos theory is just always going to happen, and so you always kind of have to be on the lookout for people doing things that don't adhere to a standard? Or is this something that we can fix with, say, like AI in the future?
Honestly, AI probably would be good at this. So I think it's a little bit of both. If you have documenting software in general is hard, partly because we don't want to do it, it's boring, but mostly because your software is constantly changing. Right. If you release a thing and then you don't touch it, it's easy to write documentation for that. In fact, like most tech writers from like 20 years ago or whatever, you just give them the software and they'd go play with it and write the documentation themselves fairly easily. Nowadays, if I do that, by the time they're done, I've already released a new version of it and it doesn't work the same way.
Well, and also, you have to think about what are most applications being written for now, and it's usually some kind of internet or web-enabled thing, and it is much easier to do rapid development on that than when you're writing everything in C and compiling and burning to a CD-ROM and mailing out to all your users. It's just I just kind of assume that software now is more like art, where it's never done. It's just eventually abandoned, and then that person leaves that company and they start a new company, or it just goes away. And that's finally when you can write the documentation. When the company goes bankrupt and they're not going to put out any more versions, now you can write the documentation.
I'd say the most often time I see people write documentation is when they leave a company. They're like, all this stuff that was up in my head, I need to write it down so someone else can deal with it. If they're kind. If they're not, then they just leave, and then you're really screwed.
Yeah. You mentioned something before we started recording about how an API changed recently for you, and I guess they weren't using Semver properly.
No, that was the worst part. They were using Semver, but they didn't. They didn't adhere to it. They were not predictable. So
Semver, and what is that?
Semver stands for semantic versioning, and effectively, it's a way of versioning your software in a way that is. Everyone know if you're using Semver, everyone knows what it means when one of those numbers changes, right? So you typically will have 3 to 4 numbers in a version string, right? You have the first one is your major number. So when you first release something, that's usually like 1.0 because the first version. Then you have your minor number. Then you have usually a patch is usually what they call the next one. And then sometimes you'll have a build number after that. But usually Semver really is concerned about those first 3. And the general way that it is expected that the behavior of your system will behave, the general way that your system should behave based on those is if I have an API and I'm using your API that you wrote, and you need to make a change that's a bug fix. You change the patch, right? You change the patch number. I don't have to change anything in my code. I am just using I just grabbed the updated library and it works, right? And that should also be the case for minor, but you might get some behavioral changes. The APIs don't change, right? But you might have a little bit of behavioral differences. Usually not anything that would break like backwards compatibility. And then your major changes, you change the major number, right? So if you want to roll out a new API version, there's several ways to do that. One of them would be to have in your path the version like V2 or something, and then everyone knows, as long as I'm using V2, I'm good. And then you'll often have like a latest, and then that's where you really run into problems with Semver, because that breaks Semver. But yeah, it wasn't even anything I wrote. Someone else, a product I support, had a library, had a system in it that was using an API from another team, right? So it's like, I'm supporting a thing that someone wrote, and that thing is using another thing that someone else wrote. So there's like three layers of indirection. And the underlying API at the bottom level changed. And it was now expecting different input. So we didn't change anything in our code at all. And the thing that we were using didn't change at all, but the thing it was using did. And so all of a sudden we were getting errors, and like no one changed anything on our side. And it's like, oh, they changed this API, and now it's expecting this string to come in this format instead of that format, but they didn't change the version number properly. And that's a real headache. And that's not the first time or the last time that I had to deal with that problem. It is a very frequent problem in the industry, is that people don't adhere to those. The most common place you see that semantic versioning is in like NPM packages, right? Like you've published a JavaScript package to the internet for people to use, and you're like, go grab the latest versions, and people will sit on the one dot whatever forever and just keep adding APIs. Adding APIs is fine, but if you change an API, you need to change the major version.
Right. I fully support Semver. I think it's great. But as with all standards and systems, they only work if people actually follow them.
Yep.
And unfortunately, it's not required that you use that. I mean, you can just name all your versions, different kinds of fish if you want to. And that's possible. We went from cod to mackerel. And, that could mean anything, but, it just means we changed the version. But but that would be maddening if people did that. And it's much easier if you use a standard.
That's also why I don't like code names.
Well, as long as the code names have a version number behind it. I mean, like, I'm okay with like Mac OS going with cats and place names, because they also have a version string that developers who care and need to know can get to. People, don't, and this was something you also said before we started recording, is that APIs are a concept that are like very specifically known to developers, and they're the only ones who care about it. When you go to facebook.com, you don't care that you're using an API to check on your friends list or upload a photo, even though that's there and you're interfacing with it, but like you don't need to know that. But if you're going to use Facebook's data in something you're doing, you really need to know that. And when they make changes, it's very important that they adhere to some kind of standard, because millions of people could have their stuff break. To use an even better example would be like Twitter.
Yep.
Or X, whatever you want to call it. That when they started changing their API rapidly and just making they're still probably making, I don't know. I'm so out of the Twitter world these days. I don't know what they're doing, but I just know they've done lots of crazy things that without announcing it, without telling people, breaking stuff left and right. Who cares? And that matters that you do that when you have millions of people, relying on. Like I remember Twitter being one of the most popular web APIs. Yeah. At one point, because everybody was using it and everybody wants to get their tweets, so they want to get someone else's tweets, or they want to get stats about those tweets. And there was an API, a public API that you could query and get that information and put it on your website or use it in your, spreadsheet or your whatever.
I had an IRC bot that would write to Twitter.
Yeah.
And if you responded to it, would show up in the channel. which now that I think about it is remarkably similar to a bot that I have written recently for work.
Yeah, I mean, Slack is a similar thing where lots of people have written bots, and if Slack changed their API so that your code didn't work and they didn't update the version, that could throw a lot of people for. I mean, like I said, this really, programs before the web obviously had interfaces, and they may not have called them APIs, but if you wanted to use a library in your code, you had to know what the API was so that you could call the right functions with the right arguments, et cetera. It's just now that the web is huge and has been around for 25 years or whatever, it's just so much more. It's just everywhere. There's so many websites with so many APIs that so many people use that it's everywhere. And so it's more in the kind of, popular consensus or culture. I think that's why, I think about APIs as being, even though they're still a very dev-y kind of term, you're using them all the time without even knowing.
Yeah. And I think you run into things like what happened with Twitter. Where the API, where they just didn't care that they were screwing over people by changing the API, because they didn't view the API as being part of their service. They viewed the service as being Twitter, right? The Twitter client that people see. And in a lot of ways, it is. Except, and Reddit recently went through a similar situation like this.
That's exactly what I was thinking of. Yep.
Where it's okay, you're costing us money to do this, and you're not going through our way, so you can't. So I can't inject ads and blah 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 to make money. Capitalism. And so it's all right. Well, we're just going to make it so either you have to pay a whole bunch of money to do this, or we're just going to break it or take it away entirely. There's that can be justified. Not to me, but. But, from a business perspective, it makes a lot of sense. And most companies don't provide public APIs, If you want to go and query a list of movies off of Hulu or something, I don't believe that they have a public-facing API for that. But most of the users of those things do consider those third-party interfaces to be part of the product, I almost never use the Twitter client until they kept breaking all the third-party clients, and eventually I was just fine. It's this horrible interface that I don't like.
I think AI and scraping for content for AI definitely accelerated.
Oh, I didn't even think of that.
Let's everybody have a public API that you can. Let's freely share information. Yay, happiness. Oh wait, capitalism. Nope, got to pay for it now. I mean, it happened over, I don't know, a decade plus, so I'm not sure if you could reasonably call it a bait and switch, but it kind of feels a little bit like that. It's a very common technique in companies to give everything away for free to get everybody to join in and get reliant and like it, and then turn around and make all that, turn off the faucet or start charging for it. But anyway, that's a different topic. But I did want to mention one more thing though, because you mentioned also that this term RPC.
Oh, yeah.
And how that's different from an API. What is the difference between those two things?
In a lot of ways, there isn't a difference, but in a lot of ways, there is, I guess.
Okay, then. We're done.
I think it's kind of similar to what we were talking about earlier with regards to the HTTP methods versus the actual API itself, right? RPC, what is it, remote procedure call or something like that? I can never remember what the P stands for. It's either remote programmatic call or remote procedure call. I think it's procedure. Basically, lets one computer program talk to another computer program is the simple way of saying that. An API doesn't necessarily need a computer program on the other end. It could be, it's a URL. You can type it into the search bar, to the address bar on your web browser, or do a curl command or whatever right now. That's still an API. And that's talking about one type of API, which is REST. But you've also got things like gRPC. gRPC is Google's remote procedure call framework, for lack of a better term. And it uses, for its API, it uses something called protocol buffers to kind of define those. So you've got your RPC as your method of communicating. And then the specifics about what you're communicating inside of that, that's the API. We've also got like named pipes on Windows. I've done a bunch of stuff with that, which is similar. It's like named pipe is a concept about how you communicate, and then it's like, okay, here's my specific API within this. I think that's really what it boils down to. It's like you've got technology that is allowing you to make these calls to these APIs, and then you've got the actual API themselves, which is the interface. This is how this is going to work.
Right. Yeah, I mean, obviously we're just kind of skimming the surface of what an API is, how it compares to other things. There's plenty to read on the internet, but I've been fascinated with APIs, the concept and the usage of them. Like I said, probably since I first started using something like Twitter, be like, oh my gosh, I can just get my 10 latest tweets or somebody else's latest tweets, and I don't have to go to Twitter to do it. I can write my own program on my own server and pull all that stuff over, and that's always been kind of magical. And it's kind of sad that, capitalism wins in the end. Capitalism. But I mean, if you're popular and you have content, you got to do, and you want to make money, I guess you got to do that eventually.
Indeed.
Yes. Matt has said indeed, so that means we're wrapping up this episode. Thank you for listening about APIs. If you want to listen to more discussions, you can go to hackingthegrepson.com. We come out every other week on Wednesdays for the foreseeable future. This was episode 68, and we're getting close to 100, Matt. Do you have any ideas for number 100? You got to do something special.
Binary.
Let's just... Yeah, because it's really episode... Oh, yeah, we go back in time. It's actually episode, 4?
Yep.
Nice. Okay, I'm just going to re-upload episode 4 for episode 100.
Yeah. And then for 101, we can upload episode 5.
Exactly. Oh, man. Just shortcut to content.
And then we'll have to actually come up with something for 102.
Yeah, but until our next shenanigan, we now return you to your regular scheduled lives already in progress.